Let's work an example. Alcohol abuse is a serious health problem on college campuses. A nationwide survey of students at 140 four-year colleges in the U.S. defined frequent binge drinking as having 5 or more drinks in a row, 3 or more times in the past 2-week period. Of the 17,096 students they surveyed, 3,314 met this criterion. Assume the data represents a simple random sample of four-year colleges. So the first thing we want to do is calculate the prevalence of frequent binge drinking on college campuses. And we'll also want to make a 95% confidence interval for this estimate. So before we get started here, let's just take a brief moment to consider if our assumptions are met that we need to have to use the normal model to help us with this. We do have a simple random sample. The criteria for the binomial are met. If you think about it, you're considered a binge drinker or you're not a binge drinker. I would hope that each college student's drinking habits are independent of the next, and there was a fixed number of students that they asked. I think we have the assumptions that need to be met in order to use our normal model. Okay, let's proceed. So what you see that I did here at the top of the screen is that I took the 3,314 students who qualified as binge drinkers and divided by the total number that they surveyed. This works out to just about 0.194. So 19.4% of students qualified as binge drinkers. The complement of that is 0.806 or 80.6 were not considered binge drinkers. Now they wanted us to use a 95% confidence interval, so this is that prevalence factor they wanted to know. The prevalence is about 19.4% students are binge drinkers. And they wanted a 95% confidence interval, so let's remember we're going to use 1.96 for Z star. So let's take this information and put it into our formula for a confidence interval for a proportion. Here's that formula from a few slides ago. And we're going to slowly start to plug in what we know. In this step, you can see I put the 0.194 for p hat, the 1.96 because we're doing a 95% confidence interval for Z star. P hat and Q hat go in the numerator of this fraction, and then we divide by the sample size, which is 17,096. Whoops. Let me fix that. I inverted a number here. All right. Don't worry, our calculations are right from there. That was just a typo. Okay, so we have this in here. And then we're going to take the right-hand side after the plus or minus, put it in our calculator and simplify it. This might be the point in the video where you're going to want to pause and try this on your own to see if when you simplify this mathematical expression here that it comes down to approximately 0.006. Try that real quick. Okay. The last part of this is to evaluate the plus or minus that are between these two quantities. So on the left and the right, I'm going to split it off. On the left, I take the 0.194 and subtract off the 0.006. And on the right, I take the 0.194 and I add on the 0.006. Now what 0.006 is our margin of error. So you can see I've added and subtracted it to what our sample told us. The results are 0.188 and 0.200. So if I take that and put it into a meaningful sentence, what it's telling us is that we are 95% confident that the true proportion of all college students that binge drink is between 18.8% and 20%. What I want to do next is show you how you can accomplish the same thing if you don't like using your calculator to manually calculate this. We can again use StatCrunch to help us with some of the busy work. So if you could open up StatCrunch, if you want to do this along with me, that's great. If not, you can just watch it and then try it later on your own. Open up StatCrunch to our spreadsheet. and we're going to navigate from Stat button to Proportion Statistics, one sample with summary. And once you navigate in, this pop-up box will appear. So what you're going to do is the number of successes, that's our numerator. And the number of observations is our denominator. So basically they don't want to know the 0.194 that we had earlier. They want to know what exactly was in your numerator, what were the number of successes, and what were the number of observations. And again, remember, success is just a word we use in statistics. It doesn't always mean the event is successful. I don't think any of us agree that binge drinking is a successful thing, but since this is what the researchers wanted to look at, this is what we consider a success. So we put that in. Then you have to click the bubble down here, make sure it's clicked on, and then you give StatCrunch the confidence level we want. And in this case we wanted 95%. And you can put any level you want in here, 99, 90, 47. I don't think we'll use a 47, but this is a box that can be edited by you. Once you get those set, hit Compute, and what you'll see is a new pop-up box in the screen that looks like this. So you can see it summarized our results. It reminded us what our numerator was, what we entered as in the denominator, in case you notice you have a typo like I did earlier. What that works out to be is a sample proportion, so the count divided by the total is that 0.194 that we used. Here's our standard error. That should look like a familiar number. We doubled it, right? So that's where the 0.006 came from. We essentially doubled it. And we have our lower limit and our upper limit of our confidence level. These two numbers are essentially what you're seeking out. This is the 0.188 when rounded to 3 digits, and the 0.200 when we round to 3 digits. This is a reasonable, valid way of working the problem if you like this way, and you can use it on tests and quizzes and homework problems if you prefer to use StatCrunch.